More?
That one.
Dr. Susan Francis and her colleagues are showing just how powerful is our brain's drive for energy-rich fatty foods.
Okay, I think we're ready. So we're interested in which parts of the brain are responding to different concentrations of fat, different fat levels. Fat's very important because people are always craving more fats and the reward concepts of fat, and we're interested in which parts of the brain are being used for those responses to fat.
What? Everything.
Okay.
The team prepares a series of energy-rich drinks whose fat content ranges from 5% to 30%.
Here he comes.
Okay.
A subject is put into an MRI scan, which will register his brain's responses. He'll drink the fat-filled liquids through this tube. First, he's given the 5% fat drink.
Okay, we're going to start the fMRI scan now. So the first fat level is 5% fat, which is very similar to whole milk, and we get very low brain response to that concentration of fat level.
The scan reveals his brain hardly responds. 10% fat drink.
The next level is the 10% fat, which is very much like the single cream level. And what we're seeing at this level is we're seeing the taste areas of the brain respond to the fat.
This time, much more of the brain lights up. Now, the 30% fat drink is administered. And it's what happens next which is so surprising.
So the highest level of fat we're giving is the 30% fat, and this is very similar to double cream. And this activates not just the taste, but also we see touch areas in the brain associated with the texture of the fat in the mouth. And we also see reward areas of the brain associated with their response to that rewarding property of the fat.
What's surprising is that a part of the brain normally associated with touch is now activated. Our mouth has even used our sense of touch to examine in fine detail the texture and viscosity of the fat. The experiment shows that over millennia, we have evolved a battery of antennae to further our quest for fatty food.